Exam 1 review, part 5. This is question number 24. A bicycle with a 19-inch diameter wheels has its gears set so that the chain has a 7-inch radius on the front sprocket and 3-inch radius on the rear sprocket. The cyclist pedals at 200 revolutions per minute. So in this case, we have a bicycle. I need more space to work this problem. So let me just illustrate. We have a bicycle. I'm going to draw the back wheel of the bicycle. Here is the back wheel of the bicycle. And here is the rear sprocket. And here is the front sprocket, which is basically the pedal. So I'm going to say this is the pedal and this is the sprocket. And then there is a chain running through here. There is a chain that runs through here. And then there is a pedal here. I'm not an artist, so I will leave it out like that. So I'm just going to remove this for the sake of illustration. The radius for the front sprocket is 7 inches. So this is 7 inches. And then the back sprocket is 3 inches. So for the pedal, it is 7 inches. And for the sprocket is 3 inches. So I'm going to say this is sprocket and this is the pedal. So this is pedal and this is sprocket. We know also that the radius, the diameter of the wheel is equal to 19 inches. So let's keep that in mind. The idea here is very simple. So we know that the linear velocity of the pedal, this one, should be the same as the back sprocket. So I'm going to say the linear velocity of the pedal should be the same as the linear velocity of the sprocket. That is the first fact that we're going to utilize here. The second fact we need to utilize is since this circle and this circle have the same center, the angular speed of the small circle or the sprocket should be the same as the angular speed of the wheel. So again, the angular speed of the sprocket is the same as the angular speed of the bike wheel. That is the second fact you need to know. We're going to use these facts later. What do we have? We have the diameter of the bicycle is equal to 19 inches. Again, this is diameter, which means the radius of the bicycle is equal to 19 over 2 inches. We also have the angular speed of the pedal, which is 200 revolutions per minute. Okay. Now, we know that the angular speed is useless when it's in revolutions per minute, so we need to convert that into radians per minute. So we're going to say the angular speed is equal to 200 revolutions per minute, and we need to convert the revolutions into radians. So 1 revolution is equal to 2 pi radians. These will cancel, and the answer is going to be 400 pi radians per minute. So that is the angular speed of the angular speed of the pedal. Now we need to convert the angular speed of the pedal to linear speed, because we know that the linear speed of the pedal is the same as linear speed of the sprocket, but but the angular speed are not the same because the radius is different and they don't share the same center. So we're going to convert. We're going to say the velocity, linear velocity, is equal to the radius times the radius of the pedal times the angular speed of the pedal. That is a rule. So if we apply that, then the linear velocity is going to be 7 times 400 pi. Now it's going to be measured in inches per minute. And we can basically convert radians per minute here to linear velocity by multiplying by by multiplying by, we say 1 revolution. Instead of doing radians, we say 1 revolution is 2 pi r, and it's the same exact thing. So now we have, this is equal to 2800 pi inches per minute. We know that the linear velocity of the pedal is the same as the linear velocity of the sprocket. We know that the linear velocity of the sprocket is equal to the radius of the sprocket times the angular speed of the sprocket. So we don't know what the angular speed of the sprocket, but we know that the linear speed of the sprocket is the same as the linear speed of the pedal. So that is equal to 2800 pi inches per minute equals the radius of the back sprocket is 3 inches, so 3 inches times the angular speed of the sprocket. Now we're going to solve for the angular speed of the sprocket, so we're going to divide both sides by 3. So angular speed of the sprocket is equal to 2800 pi over 3. And since the inches are gone, the remaining is going to be radians per minute. If you divide these numbers, you get the angular velocity of the back sprocket is equal to and you can leave it like that instead of doing the math right now. We can just leave it for later. 3 is about, let me leave it like that. So I'm going to just write it like this. I'm going to say it's 2800 pi over 3 radians per minute, just like this. There's no need to write it again. Let me save some space. Okay. Now we have the angular speed of the back sprocket. We're going to convert it back into a linear speed for the back sprocket. And we know that the linear speed of we know that the angular speed of the bicycle is the same as the angular speed of the sprocket. So now we know that the angular speed of the bicycle is equal to 2800 pi over 3 radians per minute. We're going to convert that to linear speed. We know that the linear speed of the bike, which is what we need, is equal to the radius of the bike times the angular speed of the bike, which is equal to the radius of the bike. We know that that's 19 over 2 inches times 2800 pi over 3 radians per minute. So now the radians will be ignored because inches times radians is equal to inches. And we're going to do the multiplication. So it's going to be 19 times 2800 pi inches divided by 2 times 3 is 6 over a minute. So inches per minute. If you do this calculation, it's going to be approximately 27,855.45 inches per minute. So that is the speed of the bicycle. That is the first answer. The second part of the question asks about what is the speed of the bicycle in miles per hour. So we have it in inches per minute. We need to just convert that speed. So the speed of the bike, which is the linear velocity of the bike, is equal to 27,855.45 inches per minute. We know that 1 foot is equal to 12 inches, and we know that 1 mile is equal to 12 feet. So now I just converted. I'm going to cancel feet with feet, inches with inches. The velocity is equal to 2788855, sorry. 55.45 times I made a mistake here. Just a second. That is not 12 inches. 1 mile is 5,280 feet. I don't know how I wrote that one. Okay, so again, feet is going to cancel with feet, and you will have the velocity is equal to 27855.45 divided by 12 times 5280. And now this is miles per minute. We need it in hours. So we're going to say the hour has to be in the denominator. So 1 hour is equivalent to 60 minutes. Now minutes is going to cancel with minute. And we're going to say this is 27855.45 times 60 divided by 12 times 5280 miles per hour. And that is the velocity. If you compute that, I'll compute it and I'll be right back. So I did the math here. The velocity is equal to, or the speed is equal to 26 point, rounded to 2 decimals, 38 miles per, or miles per hour, like that. And that is the second answer. And here is our first answer right here. So that is the velocity or the speed of the bicycle in inches per minute, and then we converted that to miles per hour. I think this is enough for one video, so I'm going to stop here. I'll be right back with the rest of the videos.